Good morning. Myself, C.D. Prem Kumar, Assistant Professor from Department of Information Technology, going to deliver a lecture on Embedded System Design. In this video, we're going to see about the components for embedded programs. So coming to the components for embedded programs, here there are three important components that are used in embedded software. The first is the state machine, then circular buffer, finally comes the cube. Here, state machines are well suited to reactive systems such as user interfaces. Coming to the circular buffer and queues, they are very useful in some signal processing concepts. So in this lecture, we are going to give some importance on state machines. So what is the state machines? Here, when input appears intermittently rather than as periodic samples, it often convenient to think of the system as acting those inputs. So the reaction of the most of the systems that can be categorized in terms of input received and the current state of the system. So we have to see if you focus on one node, and we have to see what are the importance of the node, and what are the changes it will do in to the other nodes. Then we go to the other node that acts as your current node. Then we have to see what is the usefulness of that particular node. Okay, so here this leads to a finite state machine style of describing the reactive system's behavior. So the state machine style of programming is also an efficient implementation of such computations. So let's see some of an example involved in state machines. Here, this diagram shows one of the state machine, right, of a simple seat belt controller. Here, we have various nodes as idle. See here, we have various nodes as this idle, then seated, then belted, finally buzzer. So all these are the four important nodes involved in simple seatbelt controller. Here, if you take the idle is nothing but there is a no seat. Then if it is a seat or a timer on, then it comes to the seated. Okay. Then finally, once you're seated, then automatically timer gets on. And once if you remove the seat belt, then automatically the buzzer gets on. Then from buzzer there is a arrowhead directed to the belted. So once buzzer is there, it indicates that the particular person who is being seated won't hold the belt. So then coming to the seated, once if you are seated, then once if you take time to uh, mm, belt once if you take time to belt the seat, then automatically the timer gets on. Similar way, once if you belt it, then it is nothing but you have been settled down, and you are in a position to drive the car. Okay, then finally from buzzer to idle state indicates that there is a no person is seated, and so that the buzzer is automatically off. So this particular state machine tells that if a person is being seated or not. So it can be indicated with the help of a buzzer. So this tells you about a simple seatbelt controller. So we see it in very detailed manner. So coming to the system, it has three inputs and one output. So the inputs which we are going to focus when we have already seen the diagram in the previous slide. So here the inputs are sensor for the seat, yes, to know when a person has sat down. Then second input is a seat belt sensor that tells when the belt is fastened. And timer is very important, that goes off when the required time interval has elapsed. So these are the three important inputs. Then you have only one output known as a buzzer. Okay, so appearing the state diagram which have already been seen that describes the seat belt controller's behavior. So we have seen the idle state. Mainly the usefulness of the idle state is when there is no person in the seat. It indicates it is an idle state. So when a person sits down, the machine goes into the goes into where into belted, and finally the timer gets turned on. So if the timer is off before the seat belt is passed in, then the machine goes in the buzzer state. That is, the person is not yet being seated, so automatically the timer will get on, so the buzzer will get operated. Because once if you started opening the door, you must have to settle down fast. Then if not, the buzzer will turn on. Then if the seat belt goes on first, it enters the belted state. So all this we have discussed in the state machine diagram. Okay. So the same state machine diagram has been implemented using a C program. Let's see the code of a C. So here you're going to define what is the idle state. Then you have to define seated. Then you have to define belted state. Finally, you have to define a buzzer state. Then the switch case, you have to we have used the switch case statement. So the state, going to switch case is used in a state, that is to check which is the current state. So various cases you have. The first case is idle. So what happens in idle means state will be in a seated mode, state will be in seated, then timer will be true, timer on will be true, then state will be seated. So default case is self loop. Okay. So idle is nothing but there is no person in the seat. If a person gets seated, then the timer gets on. That is the meaning of this. Then next case is seated. So the same state is belted. That is won't hear the buzzer. If a person gets seated, no need to off the buzzer. Else state did not put the belt in a time. That is, if a person is seated, then he is seated, but he doesn't fasten the belt. So if he doesn't fasten the belt, then automatically the buzzer gets on. Right. Say next case is belted. So here the state is idle, so the person left. Else if seated, the person still is on the seat. These are the two important things you have to follow it in the case belted. Then finally you have a buzzer. So what is the importance of buzzer is here the state is belted, that is it is on or on turn off the buzzer. So if a person is belted, no need of the buzzer, it gets turned off. Else, in else case, no one in seat turn off the buzzer. Okay. So all these are the very important uh, parts, and all these acts as your current state, and all these are the inputs, and an output is focused for the particular state machine example. So it is implemented using your C program. So far we have discussed about three important components. One is state machine, another two circular buffer and queue. So the circular and buffer and queue we have not focused here. We have seen what is a circular buffer and queue, and we have given importance to the state machine with the help of an example. Thank you.